Something like that.
Oh, it's so boring.
Boring. So we can do one more
Really? I
class.
don't know what is this.
We intake 2 until 1.
You're intake 1.
Jerry, you're intake 1. Bruce is intake 2.
Bruce gonna have
Bruce
like
is
that
intake 1.
this week.
What does
Yeah.
intake?
Intake means when you started. First start or second start?
So the start of September.
First start.
Bruce said exam this week.
Yes, it's physics tomorrow.
Oh, really?
Maybe he'll show up.
We can send a message.
Yeah, you should remind him to go to
Call
physics
him.
test.
Call him. Hey, Bruce.
Time for physics. Alright.
Math.
No, it's time for Bruce. Okay. Can I have a look at those questions? Are they stupid? They're stupid, aren't they? Oh, good grief. I can't believe we have to do this.
Oh.
I hate it. I already hate it.
Oh!
I don't even know what is that.
Me too. I feel like I hate it. How many words?
Okay, let's start.
What?
We'll start, Chrissy. I apologize now for this topic. It's so boring, but we have to do it. Okay. So we have just like in science and physics, chemistry or biology, we often collect data, and there's really two types of data we care about in engineering. We have discrete data and continuous data. So what's the difference between discrete and continuous? Well, discrete data can only be certain values. Let me give you an example. If I was to ask what grades students got, they can only get A, B, or A star, C, D, E, or U. No, for here. That's all you can get. We call this discrete, only certain values, okay? But if I asked you what score you got, well, that could be 82.5% or, 89.1% or 40% or whatever. So this one is continuous. It can take any value that we might have in between. So how do we group these together? Well, this one is easy to do because we can do it by making what's called a tally. Does anyone know a tally? Yeah, that's it. Do you know?
I thought it's like, they like what's it called? Like the accounting thing, they have to be like this, they don't have to tally with this.
Yeah, that's as a verb. You can use tally as a verb and as a noun and so on. And as an adjective as well. Can you use it as an adverb? No. Tally as a verb means count. Tally as a noun is what I'm about to do. So imagine you have something like A, B, A, C, A, B, C, A, C, B, A. Tally is when you count like this. You have A, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3. And then B, 1, 2, 3. And C, 1.
Oh, still counting.
C is 3, sorry. It's just like in China when you do that thing, I can't remember, where you go, oh, this and this, and you do a thing and you do a thing, and so on. Yeah. You know what I'm talking about. What do I do first? I do this? No, this one?
No, this one.
Middle.
Hang on.
Here.
Show me. Yeah, but what do I do? I know that, but what do I do first? Which one?
Horizontal.
Horizontal, vertical, right?
Yeah,
Right.
Vertical.
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 Yeah.
Horizontal.
Yeah.
Yeah. 1, 2, 3, 4, 5.
Yes.
Yeah. In the West, it's easier. It's 1, 2, 3, 4, 5.
It's not like this. Angle.
I know, isn't it?
No, this is a word.
It's not beautiful.
No, I mean.
I know. I do.
I
I do like this, Monica, because it just looks nicer. Because you can see that this is a 1, this is a 2, this is a 3, this is a 4, and this is a 5. I know you get the same thing here, but it's not as pretty. So this here, this is called a tally. Yeah, or it's also...
Italia.
Oh, guys, come on. And I can write the total here. 8, 3, 3. And these totals, does anyone know what they're called?
Total number.
Frequency.
Do we need to write out the discrete and continuous?
No, I'm just giving the idea. Yeah.
The total of all experiences is frequency.
No, actually, no, you would say like the frequency of A, the frequency of B, the frequency of C. Yeah?
And the total frequency?
Yeah. Yeah? So like I said, easy peasy. As long as you can count, which is what you first learned how to do in maths class. Yeah. You know, 1 apple, 2 apples, 3 apples, then you can do this. You can count, can't you? Yeah. I'll give you, plus and minus. You can do this. I'll give you an example. Like you have 2, and then you minus 1. And what do you have left?
Wait.
Minus 1.
True.
It's like A totally and A frequency, B totally and B frequency, all of them.
Yeah, well, this whole thing is called I suppose you could say, Chrissy, this part here is a tally, and this part here is the frequency. Now, the whole thing, you could call the whole thing a frequency distribution.
Oh.
The name of the lesson. Frequency distribution. The grades. This is this is like the data.
Right.
The A totally is the Y and A totally.
A tally.
The first A.
Like or da.
Oh.
Okay.
Oh my
Use
goodness.
a small word, like why use a chapter A?
Yeah.
It's your
Yeah.
What should I have used? Tell me.
Small A.
But it's this.
Because the data is big.
You can this is a tally.
Oh my god.
This is yeah.
This is good.
Yeah.
Yeah, that's much better.
Oh.
Yeah.
Satisfying.
The opening before 10.
Huh?
The add in the
Really? You think so? I guess maybe. But I think the point I'm trying to make by putting what I'm trying to make is, because tally can be used as a noun and as a verb and as an adjective. If I just said tally by itself, then you don't know if I mean a verb, a noun, or an adjective. But putting the a in front of it can only be a noun. It can't be a verb. You can't say a kick or a push. But you can say a tally.
I give him a push. Why not?
You can't say I have a push. This is a push. You know what I mean?
Well, you might say I will push.
What?
Yeah, I'm push.
I never push. You can say that.
Guys, don't be weird, please. Okay, continue. So, that is what you do if it's discrete. But what do you do if it's continuous? So, if you have something like 4.1, 4.9, 5.2, 6.11, 2.2, what do you do then if you have something which is continuous? What way could you put this in a table?
4, 2, 5, 5, 2.
Yeah, you can put it together, what's called a grouped frequency. So you need to put it into sort of what we call classes. So, can I scroll down?
No.
No.
Yes.
Well, don't write down the data, just the title, group frequency, and I'll give you a table now. Yeah? Okay, can I scroll down? So, let's make up some data. And you know what, actually, I will do this in the office program so I can show you a bit clearer. This is something that you might have in chemistry or physics. You have all this data, but you want to display it in a way that's easy to read. So you don't want to list all the data. You know, if you ask 1,000 people their height, you don't want to write the heights 1,000 times in your report. You want to give somebody an easy way to see everything. Okay, so I'll just make up some numbers. 2.11, 5.1, 6. Oh no, this will take a while. Let me see. Rand. Okay, now let's multiply this by 100. Okay, and we'll make it to 1 decimal place. Okay, and let's make, I don't know, we'll make 100 of them. Steady. Okay, so I have 100 random numbers, and I want to know a nice way to put them together. Okay. Whoa-ho-ho! Oh, come on. Steady. Steady. I just want the numbers. Delete. Awkward. There we go. Alright, now I have my 100 numbers. So, if I was to make a table, I think Jerry had the idea. Just be careful, there's 2 ways to write the table. By the way, this is called this is called a class. So, in the table, you have many different sections. So let me just look at one section, which is called a class. So on the top you have the data, and on the bottom you have the frequency. And here we can write something like A to B. There's 2 ways to write it, okay? The way I like it is by using the brackets. So for example, if I write 5 to 6.2, it's very, very clear when it's in it and when it's not. So for example, if I have 5, does 5 go into this class or not? Yeah. If I have 6.2?
No.
No. Because this means not included. Now, if I write 5 to 6.2, it's not clear. What do you do with the 6.2? You would have to tell the person in another sentence what to do at the upper end. So you would have to say under the table, you know, inclusive on the left, not inclusive on the right. Very, very messy. It's much easier if you just write this. Okay, so don't do that. Instead, this is better. Now, what about a situation like this? 5 to 6, but then the next box is 7 to 8. Now, this might seem like a mistake, but it's actually not, because you can decide which one to put it in. If I have 6.2, which class does that go into?
6.
Yeah, why? Yeah. If I have 6.6, it would go into this. Into this one. So if you write it like this, in your head you have the class boundary as 5 to what?
6.
No? 6.5.
0.4. Oh, yeah.
Oh, sorry, thank you. Well, I guess my table starts at 5 in this example. But you're right, if it continued then it would be 4.5 then, yeah. And then this next one here, 7 to 8.5, and maybe there's more to the right. Oh my goodness! I need more coffee. 6.5 to 8.5 open. Okay, these are called class boundaries.
So many new words.
Because if you have 8.2, you can round down to 8. It goes into the 8 box. But if you have 8.6, it must go in the next one.
Yes.
So these words are important. This is called a boundary. This is where the frequency goes. This is where your data goes. The data range, I should say. This part here is called a class. But this table is called a grouped frequency table. And this is best. And this I no like. No like. No likey.
If you need more coffee, I can make it for you.
I know, I've got loads here, thanks.
What's that?
Huh?
What is that?
What is the best coffee?
No, I mean.
The best coffee, let me think.
What is the best?
No, not best coffee. The best one is the brackets. This one.
Huh?
This is the best way to write it, if you can.
Best way.
Yeah.
No, it is not. What is 8.55?
This is the best way to write it. Trust me.
6.55.
Dude, leave me alone. Can I continue? Are you really asking me a question or are you trying to troll me? What are you doing?
What is 6.52?
6.52 will go into this one.
Okay.
Yes? Are you finished trolling? No more trolling? Problem, bro?
Okay, this is the best.
Okay. Continue. So, now that we've talked about that, we can go back to my example here. We have to make a grouped table. Now, we need to decide where to start and where to finish on the table. Okay? So we would need some information. What would we need to know from the data? We would need to know the minimum and the maximum. Okay? So the first step is we'll get the minimum and we'll get the maximum. Okay, so that's equal to min A1 to A100. The smallest was 0.4. And maximum value, max A1 to A100. Yeah? So the biggest was 96.8. Okay, good. Next. What else might we need to know? If we want to make a table, we should know the minimum and the maximum, but what else should we know?
The middle.
Yeah, how many intervals? Now, before we work that out, we should know how much data we have. So, we call that the n.
99.
Yeah, no, it should be 100 actually. It's 100, which is what I did on purpose. Yeah. Now actually, I want to just make it a slightly less than 100, just so it's not a nice number. So 99 we'll say now. Okay, 99 then. Now, the next thing we want to do, how many classes should we have? How many boxes, how many bins should we have?
5.
Well, I mean, how can we decide?
We pick a number.
We can, and that's okay, but there actually is a way, a nice formula or a nice way to decide how many boxes. Because, think about this, if you have only 3 numbers, it would be stupid to use 3 boxes, wouldn't it? Because then you have 1 box with 1 number.
Yeah.
It's kind of stupid.
And
If
that's
you,
one place.
yeah, well, if you had 1,000 numbers, likewise, it'd be kind of stupid to have, say, 500 boxes, because then each box only has 2 numbers in it, and it'd be a very long table. So we need some way of knowing what's a suitable size, And it depends on how many data points you have. And in fact, to know the number of boundaries, the number of classes, it's equal to square root of the n.
Wow.
Rounded up. So, round up.
10.
So I should have 10. Now the reason for this is actually is a statistical reason, which we don't talk about in this class, but in statistics the square root of the sample size is an important number. Think back to your physics lab report when we were calculating the uncertainty of the slope of the gradient. Do you remember the formula? It was uncertainty in y over uncertainty of x divided by square root of n. In fact, when you study more the statistics, you will discover square root of n to be all over the place. It's quite common. It's a bit like in physics. Remember I said the inverse square formula is common in physics, where you have a square in the denominator. Like think about Newton's mm over r squared, or Coulomb's qq over r squared. In statistics it's the same deal. The square root n is a repeating calculation. Okay, so we should have 10 classes. Yeah. Now the next thing we want to know is how big should each class be? How big should it be? How can we get that?
Why?
Huh? No, the x-axis. Like how big should we make each box to fit the numbers?
Divide by 10. The maximum.
Yeah, so we should do the maximum minus the minimum divided by 10. So that will be this divided by...
Minus.
Oh yeah, sorry, let me see. This minus this divided by this. Yeah? But there's a small problem with this. Can anyone think of what the problem might be if we try to use this?
I mean...
No, go on, yeah.
9.64 is not a good number. I mean, you can't go 9.64.
I know, that's actually not the problem. That's actually okay.
You have to start from 0.
No, you can actually start from the minimum, 0.4.
It doesn't fit the number.
No, yes, but how? See, think about this. If you start at 0.4 and you go up in units of 9.64, you will finish on 96.8. And you might say, well, so what? That's the end, 96.8. But think about the last box. The last box does not include the 96.8. So if you do this, you can't fit the last point into your table. Yeah.
Can we just make a section for the last one?
No, we'll try not to do that. No. So what we'll do is, rather than using 9.64, that's it's a little bit too tight, isn't it? We should maybe use something a little bit bigger, just a little bit bigger. So it's okay if we go a little bit past the last one, or if we start a little bit early. So the way we do that is, rather than dividing by 10, instead of dividing by 10, we should divide by we want to make it bigger, so we should divide by a smaller number. So we'll divide by minus 1 then. So we've made it a little bit bigger. Okay? Now, 10.7111 is stupid. All my data has only one decimal place. Right? So it will be more appropriate to round this to one decimal place to keep it the same as the data. You understand what I'm saying? So, okay, so now we have 10.7. Great. Now, where do we start? So let's make our table. So the first one here, I'll put it here.
0.
We start at 0.4?
No, it's 0.4.
No, we can actually start a little bit to the left of 0.4.
Sure.
Because we don't want to start exactly at the first point. We don't want it so tight. Well, how far to the left we move? What I'll do is I'll start at 0.4 minus half of this number. This is called the width, by the way, how wide each one is. That's not right. Oh yeah, that's right. Yeah.
The size of process.
The class size, yeah, or the class width, yeah. And how far do I go in the next box? Well, it'll be this plus the width. Okay, so this is the first one done. Where's that thing that makes the boxes pretty? You know what I'm talking about, where you can put boxes around it?
Yeah. Well, I don't know the color.
You?
No, it's one of the buttons.
Oh,
That's
for the
border.
car.
Where? Oh yeah.
Nothing happens.
So you have to slide.
This is so
I mean borders, and then you have to get this
Hold on. Where is it?
Microsoft Word.
That's
is better.
border style? Maybe there's something else here.
Slide down.
Come on, go back up. Go up. Ah, okay. Just use your imagination that there's boxes around it. Okay. Do you know what? I'll put it in a different colour. I'll make it a yellow.
No.
Yeah. All right. Now. Yeah, I know. Next one. So the next one, it's a bit like this is the start and this is the end. Okay, so where does the next one start?
5.
It starts here, but just remember, just remember this is like this, closed, and then open. This one here, start at 5.75, closed, and then where do I finish? This plus the width, which is that. And then this gives me my next box. So, let's copy this. This is number 2. How many do I need? 10, isn't it? That's 3, 4, 5. Oh no, hang on. That's not right. Hang on. Equals this. Equals this plus this dollars. That was the problem. Alright, what number is this one? The 4th one?
The third one.
That's the 3rd one. Okay, so this is the 4th. Good. No. What?
It doesn't move.
There, okay, that's the 4th one.
Yeah.
5th one. 6th. 7th. 8th. 9. Now, do you notice this works really nicely because the smallest point and the largest point, they fit nicely in my table. It's not like my table is pushed right up to the point. It comfortably fits in the last box, and the smallest one comfortably fits into the first one. Okay. Now I should. How do I do merge actually?
Highlight them.
Yeah.
And then right click. There's a word called merge. I mean, for words, it works.
Yeah. So there's merge. So I need to merge these because I should only have one number, because this is the beginning, this is the end, and this is the frequency. So this is the range, and this is the F. Okay. So here now. Merge.
Let me just one shot highlight all of them.
No, because then it'll merge it all into one giant one, wouldn't it?
Oh.
How does it know I want to merge every 2? It doesn't. Or does it? Is that them all? Last one. Merge. Okay. So the first one is minus 4.95 to 5.75. Now I think Excel can count this for me. Let's see what the heck happens. Count. Count blank. Count the arguments which meet the criteria. Okay, I think it's this one. Next.
Yeah.
Range is A1 to... No, cancel. Count if S. Yeah, okay.
What is if S?
I have 2 criteria.
Oh.
Alright, so the first one is
A1.
A100, A to A99.
Yeah.
Right, in the first one, I need it to be bigger than...
Bigger or equal to.
How do you type in, like, the variable?
Yeah. I mean the variable changes. You have to do that manually for all of them.
No, could I just type in A1 and we'll figure it out?
But it is not A1.
I know, it's all of them, isn't it? Yeah, but I want to tell Excel to count. Oh, I know, I remember now, I remember. It's been a while since I've used this function. Next. Okay, so it's A1 to A99, and I need everything to be bigger than or equal to,
Yep.
what is it?
C1.
C10. C10. And for the criteria 2, I need it to be smaller than, but not equal to,
Fine.
D10.
What about range 2?
I want it still counting this one though.
Yeah.
Yeah, then we can just put that in there.
Copy and
Do you think I need to put this in here?
Yeah.
Are you sure?
Yeah.
Really sure?
Yeah.
I don't believe you, but I'll trust you. And I don't want this changing, so I want dollars. I'm really trusting you guys. Oh no. What did I...
Oh, this is like an array.
A1, A99.
Correct.
Greater than or equal to
C10.
C10. Are you sure it was that one?
Yeah, deliver.
D10. And then
D10.
smaller than D10. Okay.
The next.
Tally says I can trust you.
You can't put twice. No, I'm just saying.
Maybe it doesn't like equals. No, that's not it.
You have to put and. Or you have to put at.
Stop guessing!
At bigger or equal to. No?
Count.
What about just in one criteria?
No, you have to be.
For my school.
No, but you can just
Maybe.
together.
Maybe. Count if just one criteria. So the range is A1 to A99, and it needs to be smaller than or equal to, greater than or equal to C10. Now let's just see if this works.
And.
You will put the and in a second. No, see, it's something.
The thing is.
Can someone just open up Google and type?
Maybe you have to like at.
Oh, do you know that? Actually,
Christy, you have it there, and Monica. Just Google how to count between two values in Excel.
This is not Excel.
Yeah, but it's the same syntax, so just do it, please. Good grief. Yeah. Pass it along. Are you kidding me? It just needs quotation marks. Quotation mark. No, that's not it.
Yeah, quotation mark.
You have to put number in the second.
You don't have
Yeah,
to
that's
put
what I
the
use
dollar.
too.
The one you use is one.
Ampersand.
You don't have to put the dollar.
Ah, that's, yeah, okay, so, yeah, but no, we were just counting how many is bigger, and 99 of them are bigger than -4. Now, can I put in the second one, but just, and this is less than C11, but it's count if S. Oh, sorry, D. I think I can do an and like this. No, I'm getting closer.
You have to type 2n.
I'll count how many is bigger and then how many is smaller.
Teacher, one time I made and the computer is maximum.
Plus. Plus.
Hang on, why is it not working anymore? It was working a second ago.
It can't be like this. Can't remove the blur.
Oh, these guys. Flip's sake. True.
Oh, you have to put column with both the bigger, equal, and the number.
And or the end.
Right, let's try this again. Count if A1 to A99
Is
bigger than or equal to and C10.
and here there is
Name.
third restricted.
A
Yes.
A1 to A99. There. No, I have it now. Don't distract me. So, this is how many is bigger, and I should minus how many is bigger than 5.75 or equal to it, and then I get what's in between. Okay.
Oh.
And is this a D?
Yeah, that's
Right. No. 89?
No, I mean like put comma together with bigger, equal, distance together. No and.
Just give me the phone.
Something the grammar that puts the range after C10.
The range again, and then less than. Okay. Right. Now don't distract me. Just help me, please. Right, I have comma, the range again, and comma, and this again, except
Small.
the other one. Smaller than. No, that's definitely not it. Yeah. Oh, count if S. 10. Okay,
What
yeah.
happened?
I figured out, or well, Monica's helpful phone there. We figured out what the command is. Should have been this. Now, if I copy this, will it change the letters from C? Oh yeah, nice. Oh, look at this. Wow, boom, 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 boom. Not too many. Right, great. So, how many in the first class? 10. Next one, 10, 3, and so on. To check that this is right, I'll just add them all up. And how many should I have if I add all of these up?
199.
99.
Oh,
Boom.
oh.
Alright. Nice. Alright, I need to remember this. Count if S.
I don't remember too. How can I remember that?
I don't know. I'll probably, when I do this with groups, I'll probably forget.
Take a picture,
Screenshot, yeah. I should watch my own video. Okay, so this is, if you were doing a report and you need to group things together, this is the way to group it. Not the one with my lab report, because this would be with a chemistry or biology report where you're collecting samples. So you can imagine like you had to conduct an experiment or go to a field and take soil samples, and you could have like say 100 samples from the field of the nitrogen level. So how do you represent that? Well, this would be a groups table would be the way to do it. Okay.
Nice.
Yeah.
I know how to do this.
Yeah, I'm satisfied with that. Okay, so can you try these for a few minutes?
Sorry, what?
The questions.
Do we need to write out the formula you just did just now?
count it?
I mean,
No.
I mean like the number of pluses, the size.
No, in the exam, they don't care. So like you could look at this and say, oh, we'll make 5, and someone might make 6, and someone might make 4. So as long as it's not a stupid number, it's fine. But if you want to know, is there a mathematical way to choose a good number? And the answer is yes, there is, and this is how. You should choose square root of the sample size rounded up, and the width should not be the range divided by 10, because that makes it too tight at the start and at the end. Instead, you should divide by 9 to make it a little bit bigger.
Those stupid questions.
I know they are, but
Like, tell me that.
I know.
Yeah, so we finish at 4.
No, we're not finished at 4. We're not finished at 4. What's the next lesson? Is there something stupid as well?
What are we not finishing at?
Oh, average is. Oh.
Let's just go to average and then do it together.
No, do these for a few minutes, and maybe we'll finish early if you're good.
You're the problem, why you ask me?
Leave poor Jerry alone. He's fine. He's drinking his juice. Leave him alone. All right. Can I close this